Greetings to the people who are watching this video. I am Alfredo Asuncion, my advisor is Sir Henderson Cabrera, and I will be presenting to you my thesis entitled Prediction and Analysis of Epitopes from Purine A and B proteins of Neisseria meningitidis through immunoinformatics approach. In Africa, there is one disease that causes severe disability, like blood infection, meningitis, blindness, and paralysis. This disease is called meningococcal disease. The meningococcal disease is caused by Neisseria meningitidis, a gram-negative bacterium that is from Neisseria cerevisiae. This bacteria spreads around 1,000 cases out of 100,000 population occurred each year, and it is famous in Sahelian and Sub-Saharan countries in Africa. Neisseria meningitis has a total of 12 serogroups, but only 6 serogroups is mostly well known to infect humans. These 6 serogroups are A, B, C, W135, and X. Serogroups A and B have the highest cases occurred each year, and it is mostly found in Africa, Australia, and US. Neisseria meningitis can infect a person through their nose and throat, like a normal bacterium. It can infect a person fast with proper care. The signs and symptoms that can appear to an infected persons are fever, rashes, altered mental status, and skin lesions. The worst case scenario are sepsis and meningitis, where the bacteria will enter the brain. The bacteria can be diagnosed through the appearance of the signs and symptoms or saliva test, called PCR. In order to eliminate this bacterium in the body, current treatments have been made. There are 2 current treatments of Neisseria meningitidis. This is early detection method and oral intake. The early detection method uses vaccines instead, while for oral intake, it uses antibiotics. The antibiotics are sometimes better during early signs of symptoms, but during late cases, it is not effective. For the vaccines to work, it targets a certain proteins in the pathogen. An example of these proteins is purines. The purines has been used in many studies, and its role is found in the infected host cell and also part of a good adjuvant for vaccines. The purines are located in the outer membrane and mitochondria and serve as a membrane transport for certain molecules, such as hydrophilic molecules and ions. In mitochondria, the purines are able to deactivate the apoptosis of the host cell through the cytokines. This activation of the mitochondria could trigger a stop in apoptosis and could react the entry and replication of the pathogen. The purines are made of hydrophilic molecules inside and hydrophobic outside of the proteins. The purines are structured in trimeric but can also be monomeric depending on the structure of the outer membrane. Inside the cell, there will be pathogens attacking the purines so that they could enter and replicate. But before they could do that, there are immune cells that would interfere and breed. An example of these are cytotoxic T lymphocytes, helper T lymphocytes, and B lymphocytes. The cytotoxic T lymphocytes directly kills the infected cells through apoptosis. The helper T lymphocytes are the ones that activate B lymphocytes through antigen and also activate the cytotoxic T lymphocytes. The B lymphocytes are responsible for producing immunoglobulins that could alert other immune cells. The CTL and HTL and LBL can be activated through an antigen. An antigen contains epitopes. These epitopes are the proteins that identify by the antibody. The epitopes are made by APC molecules like macrophages. These epitopes are made during the macrophages digesting the pathogen. The digested fragments are called epitopes. Through APC receptors, the epitopes are delivered through MHC molecules. When the MHC molecules and the epitopes are paired, it will deliver it to the CTL and HTL cells, and the cells are activated. The problem statement are the selected epitopes of foreign A and B proteins potential candidates of non-immunogenic peptide vaccine construct? And my objective of this study is to predict peptide-based vaccines against non-immunogenic based on cytotoxic lymphocytes, helper T lymphocytes, and linear T lymphocytes epitopes derived from outer membrane proteins, foreign A and foreign B. And in silico immune simulation will be used to assess the efficacy of the peptide vaccines in terms of random seed simulation steps and simulation volume. And here is no significance of the study. Here is the overview of the methodology. So the first section starts at the retrieval of occurrence in the Uniprot database. Then, three types of epitopes was predicted: CTL, HTL, and LBL. The CTL was predicted through NetCTL v1.2 server. The epitopes predicted by the NetCTL was done through immunogenicity. Only positive results was retrieved in immunogenicity. Then epitopes were evaluated through ARTAP, Voxygen, and toxin prep. The Voxygen has threshold of greater than 0.75. So all the epitopes below 0.75 are discarded. Then HLA allele partner was determined through IEDB-MHC1 binding tool. In the binding tool, a percentile score less than 1.5 was used to determine the allele partner. In HTL epitopes, IEDB-MHC1 binding tool was used to determine the epitopes and HLA allele partners. A percentile score of less than 1.5 was used as an epitope. The epitopes less than 1.5 are then evaluated through allergenicity, toxicity, and antigenicity. The allergenicity was predicted in ALERTAP, and the toxicity was predicted in toxin prep, and the antigenicity was predicted in Voxygen. The antigenicity was as a threshold of greater than 0.75 for the epitopes. After the evaluation, the epitopes was conducted through the inducibility test. The inducibility test was done using IFN epitope, IL4-PRED, and IL10-PRED receptor. The IFN epitope used to predict IFN gamma, the IL4-PRED used to predict the interleukin-4, and the IL10-PRED used to predict the interleukin-10. Then the CTL and HL was conducted through population coverage to determine the similarities of epitopes to global population. The survey used to predict the population coverage was IEDB population coverage tool. Then peptide vaccine construct was done after population coverage in the peptide vaccine. There are three key components for a good vaccine. This is candidate epitopes, strong adjuvants, and stable linkers or spacers. For the epitopes, must be immunogenic, non-allergenic, and toxic, and cytokine-inducing proteins for HLA. Along with the appropriate antigen, epitopes as strong adjuvant can boost the adaptive immune response. Then, the peptide vaccine was conducted to antigenicity, allergenicity, toxicity, and physiochemical properties prediction. The physiochemical property were conducted through program to determine the various physiochemical features of the amino acid composition and theoretical isoelectric point, molecular weight, instability index, aliphatic index, and grand average of the hydrophobicity. Lastly, in silico simulation was carried out using CIMMC to estimate the real-life immunogenic profile of the peptide vaccine. This server uses position-specific score, matrix, and machine learning algorithm. The injection was done through 3 times in time steps in direction of 184 and 168 steps. The random sequence was 12,345, while simulation volume was 10 microliter and simulation steps was 1,000 steps. For the results and discussion, the table shows the final candidates' epitopes for pairing A and B. The percentile rank of lesser than 0.8 was kept to have a high median score. The percentile rank is calculated through the integrated method of MHC1 binding tool, proteasomal cleavage, and transport efficiency. The three methods uses artificial neural network, machine learning algorithm. The allelic partners has been filtered around lesser than 1.5. Other percentile score suggests that a high binding affinity of the alleles to the signal epitopes. A total of 6 epitopes for pairing A and 7 epitopes for pairing B was chosen as a candidate epitopes because of their low percentile score, which means high binding affinity. The 6 epitopes of pair A and 7 epitopes of pair B has also have high antigenic value and a threshold of greater than 0.75, which means it can easily bind and interact to the B cell and T cell. Here is the results for pair B. So in the HL epitopes was predicted to IEDB MHC2 binding server. The server predicts 41 epitopes for pairing A and 22 epitopes for pairing B. A percentile rank of greater than 1.5, the allelic partner was determined at the lowest percentile score to have high binding affinity, while the test is used to determine that if there are inducible to IFN, gamma, L4, and L10 based on the inducibility test. There are two candidates epitopes for pair A and pair B epitopes. The importance of inducibility test is based on their function in interleukins. Currently, the HDL consists of two epitopes, two types, the T helper 1 and T helper 2 cells. The TH primarily produces the cytokine gamma interferon, tumor necrosis factor beta, and interleukin 2, while T helper 2 are mainly interleukin 4 and many other interleukins. Here are the results for LBL epitopes for pairing B. Here is the multiple sequence alignment. The multiple sequence alignment was used to determine the mutation in the epitopes. Based on the results, was discovered that there's no mutation was seen inside the 6 and 7 candidate epitopes of pair A and B epitopes. Here is the population coverage for pair B. Here is our vaccine construct. Here is the allergenicity, physiochemical analysis for pair B, the in silico simulations for cytotoxic T lymphocytes with epithelial macrophages, and here are for helper T lymphocytes. And here is the plasma B cells. For the conclusion and recommendation,